non-ideal solutions. We know solutions, homogeneous solution, heterogeneous solution, and what are these ideal and non-ideal solutions? What is a solution first? Solution is a homogeneous mixture of solute and solvent. Okay. What is a dilute solution? Dilute solution is when a very small amount of solute is dissolved in a large amount of solvent, it is called dilute solution. See, what are ideal and non-ideal solutions? For this, we should know what is Raoult's law. Do you know what is Raoult's law? Raoult's law states that the relative lowering of vapor pressure of a solution is equal to the mole fraction of the solute at that given temperature. That is, the relative lowering of vapor pressure of a solution is equal to the mole fraction of the solute at a given temperature. Let us deal with ideal solutions first. Okay, ideal solutions. Ideal solutions. Ideal solutions are solutions in which each component, that is, they contain two components, is it not? What are those two components? Solute component and solvent component. If each component obeys the Raoult's law, if each component obeys Raoult's law, then they are said to be ideal solutions. But do you think this is possible? Practically, this is not at all possible. All the components or each components present in a solution over the entire range of concentration, obeying Raoult's law is somewhat difficult. But if the solution is a very dilute solution, that is, if a small amount of solute is dissolved in a very large amount of solvent, it is practically possible, that is, the solution behaves ideally. If the solute and the solvent components are identical in their size, in their shape, and if they have similar intermolecular attractive forces between them, then they will behave ideally. These ideal solutions will be the first one. There will be no change in volume during mixing. That is, when a solute is dissolved in ideal solution, when a solute is dissolved in a solvent, there will be no change in the volume. Change in the volume before mixing and after mixing. Cv is the volume, delta is change. Change in the volume will be equal to 0 for an ideal solution. And secondly, when a solute is dissolved in a solvent in an ideal solution, there is no exchange of heat. Therefore, heat, that is here H is enthalpy. Change in enthalpy is also equal to 0. And for ideal solution, the third one is the escaping tendency of the solute and the solvent should be same as in that of pure liquids. The escaping tendency of solute and solvent should be similar to that of when they are in pure liquid form. should be equal. And there are so many ideal solutions. For example, benzene, a mixture of a solution of benzene and toluene, N-hexane and N-heptane, ethyl bromide and ethyl iodide. These are the examples for ideal solutions. Now, let us see about non-ideal solutions. Non-ideal solutions are just the opposite of ideal solutions. Ideal solutions obey Raoult's law, whereas non-ideal solutions do not obey Raoult's law. That is, non-ideal solutions are solutions in which each component, that is the solute and the solvent components, do not obey Raoult's law over the entire range of concentration. Here, the characteristics for the non-ideal solutions will be, the first one is, there will be change in volume. There will be change in volume while mixing. See, here also I have to write delta V mixing, delta H mixing. Here also delta V mixing, and the second one is, there will be exchange of heat while the solute is dissolved in the solvent. Therefore, there will be exchange of heat while mixing a solute, while a solute is dissolved in a solvent in case of non-ideal solutions. For a non-ideal solution, the escaping tendency will not be the same in pure liquid state as in that of ideal solution. That is, the escaping tendency will be either higher than when they are in the pure liquid state, or lower than the pure liquid state. If it is higher, it is said to be positive deviation, and if it is lower, then it is said to be negative deviation. Deviation means deviating from the ideal behavior. These non-ideal solutions will deviate from the ideal behavior positively. Positively means their deviation will be greater. Then it is said to be positive deviation from the ideal behavior. If the deviation is lesser from the normal, then it is said to be negative deviation from the ideal behavior.